right.
You want to give a quick try and see if your share screen is working, Sam?
Yeah.
Yes.
Go for it. Oh,
Can you see my screen?
Yep, it's
Yes.
good.
yes.
Okay.
Okay, so it's 8 p.m. Eastern Time. Uh, let's start this session, Software Engineering in Practice 4. I'm Igor Steinmeier, and I'll be the session chair. This is how it will work. We'll have 6 presentations today. Each of them will be 5 minutes long. And at the end of the presentations, we'll have a discussion, a Q&A session, including all the authors. So we don't have Q&A just after the talks, just at the end. If you want to put your questions during the presentation in the chat, it's okay. Just mark it as a question to make it easier for us to locate, and add the name of the presenter. So I will call you if you want to vocalize it, or I can read it out loud if you prefer. Okay, so to start our session, we'll have presentation of the paper entitled A Longitudinal Case Study on the Effects of an Evidence-Based Software Engineering Training by Sebastián Pizar, Diego Vallespir, and Barbara Kishen. Sebastian, feel free to share your screen. The floor is yours.
Yes. Thank you, Igor, for the introduction. Evidence-based software engineering is used by most researchers. For example, it's very common that PhD students begin their research with a secondary study. However, we know only 3 studies that report secondary studies in non-academic settings. Is it because EBS is not useful for non-academics? We don't know that. What we do know is that training is one of the main facilitators to improve adoption of evidence-based practice. We found only 14 studies presenting EBS training, and we studied them to create our own course. Our course is based on learning outcomes, and we want to teach EBS and systematic review for practical use. We have already taught 3 EBS courses, all of them at the Universidad de la República in Uruguay. Because we consider EBS training as a complex issue, at the beginning we wanted to know if our course was suitable. Later on, Barbara proposed to investigate also the effect of the course. This was really interesting. So we collected data in 3 waves between 2017 and 2021. We tried to give participants enough time to use their training. We conducted 2 surveys, and as had a very high response rate. We consider that the course adequacy is related to the achievement of the learning outcomes by the student. And for assess that, we use student self-evaluations and teacher evaluations. The achievement of the learning outcomes was in all cases above 65%, which we consider very good. Also, everybody who reported using EBS evaluated the training as adequate. We think our training had very interesting effect. The student reported using many of the skills from the course in their most of use of the skill were related to awareness of research and scientific evidence, and information gathering and information literacy skills. The results confirm that our course was adequate and consisted over the 3 years. Also, the learning outcomes facilitate tracking the student performance in each concept of practice. All the material we created is now available online in English and in Spanish. We really want this material to be used or adapted in other universities, because we believe that it can serve as a basis for more formalization in evidence-based software engineering training. We can say that EBS training makes practitioners more confident in the value of scientific evidence and foster its use to support decision making. We don't know if using EBSI will close the gap between academia and industry, but our results support the proposal to use EBSI to bring practitioners closer to scientific evidence. This is, we think, a good starting point. As in other fields, training appears to play a key role in the adoption of evidence-based practice. By now, curricular guides for undergraduate computer students don't consider evidence-based practice. But it's fair to say also that we need more studies before consider to include EBSI in the curricular guides. We know that evidence-based practice training in medicine is more effective when it is integrated with clinical practice. This can be done in EBSI training too, for example, by engaging practitioners in teaching activities. Last year, we created scenarios of use of evidence with practitioners from government and industry. We use these scenarios to improve our course, and we are now analyzing this data. If you are interested in our work, you can contact us, and you can also join our project on ResearchGate. In this project, we are using several qualitative methods to improve EBSI adoption. Thank you.
Thank you, Sebastian. Following Sebastian, we have the paper from the Software Engineering Education and Training track entitled Student-Sponsored Projects in a Capstone Course, Reflections and Lesson Learned by Ethan Butt, Suzette Person, and Christopher Dunn. Christopher will be presenting the paper today. Christopher, feel free to share your screen and go ahead. The floor is yours.
All right, thank you. Can you see my screen?
Yes.
Okay.
Yeah.
All right, good. Yeah, so I run our capstone program at UNL's School of Computing. Ethan Butte was one of our capstone students a couple of years ago, and so he's majoring in software engineering, and there are a few novel aspects of our software engineering major, but the part that we're going to focus on here is that they have to take 2 years of our capstone. So in their first year, they have what we kind of think of as our normal senior design type project. It's a 2-semester long project with half a dozen students and some sort of external sponsor other than the faculty supervisor. And we provide a lot of support for these senior design teams. Obviously the faculty member. I also have a couple of PMP project managers on my staff, and they provide a lot of guidance for the teams as well. Obviously the sponsor then, who provides the vision, the business case or is responsible for the business case for the product. And then we also bring in some volunteer coaches from industry to help out with some technical issues or some soft skills issues. So a couple of years ago, we had a group of students say, hey, we've done that first year, which they didn't put it as that meets all the curricular requirements, but they met most of those requirements. And so they asked if they could do something different in their second year, in which they are their own sponsors. They wanted to try to model a startup. And we were kind of excited about that. And for some reasons I'm going to get into, we couldn't provide the same level of support for them that we do for normal students. So we had to take away a lot of that extra support, but then we offset it by bringing in additional coaches from industry. In fact, they were very particular coaches. So these students had already been working closely together for a few years. So they'd gotten through the norming and forming stage. So they were already a tightly knit group. They had already worked on some longish term projects. So they kind of had the technical piece pretty well underhand. And so we wanted to make this happen. We didn't want to just toss them to the wolves and hope they got it right. We wanted to bring in some support without jeopardizing their ownership of their intellectual property. So our university's bylaws say that the students own the intellectual property unless it is commercializable and makes extensive use of university resources. And so since the plan was to commercialize this, we definitely had to make sure it was not going to make extensive use of university resources. And so that's where our industry partner came in. So this particular company specializes in a few areas, but one of them is helping new startups get up to speed and figure out the market analysis and the product discovery. And so they volunteered to help our team go through. Unfortunately, things got off to a little bit of a slow start. This was the beginning of fall 2020, and we were just trying to figure out how we're going to do that next year. So they got off to a bit of a start, and then they had a bit of, I won't call it analysis paralysis, but they had to do a lot more analysis than they originally anticipated. So they really didn't get to the technical part of it until the second semester. But in the process, they learned a whole heck of a lot about that product discovery. So we learned from that. And so then this last year, and this really isn't in the paper itself, we learned from that, and we were able to get the student teams started sooner, and also kept their size a little bit more manageable. And so they still had some of the churn, not quite as much as the previous team, but they were able to get into the technical efforts much sooner. And so this was kind of nifty because the students not only were responsible for the technical side, they're responsible for the business side. Is this a viable product? That was what they spent that first group spent the first semester just trying to figure out, is what product they were going to work on that was actually commercializable. So they got a lot out of that. We let them fail. That's absolutely necessary. And that way they continue through that product discovery. Now, if you wanted to try to do this yourself, there are certain issues you have to think about. For example, what your university's policies are with regarding intellectual property. What are the curricular implications, especially for your software engineering students? So if they're in a software engineering major, the curriculum guidelines actually say that the customer really needs to be someone other than the faculty sponsor, and presumably or themselves. Now, since our students did that in their first year of Capstone, we're pretty confident that yes, we covered that check mark. So just some things to think about if you want to try to replicate this. Feel free to reach us, contact us if you do want to try it. So thank you.
Excellent, Christopher. Thank you very much. Coming up, we have a paper from Software Engineering Practice track, analyzing the CMake build system, authored by Kim Hao Nguyen, Tan-Vu Nguyen, in Kuo Sang Fan. I think it's Sung who's presenting, right? Sung, feel free to share your screen. It's shared already. The floor is all yours.
Can you see my screen?
Yep, it's clear.
Yeah. Hi everyone. My name is Sang. I work at the WhatsApp security team at Meta, and today I'm going to talk about some challenges when analyzing the CMake build system. So before talking about the challenges, so the first question is, why do we need to analyze CMake build files? So to give you some context, so there are 2 billion people using WhatsApp every day. So security is very, very important for us. And unfortunately, because WhatsApp is so popular, it also attracts a lot of attackers. And these people are very talented, very well organized, very well funded, and many are even backed by some foreign governments. And the most serious attacks on WhatsApp was like 2 years ago by a company called NSO Group. And what they did was they exploited a buffer overflow in one of WhatsApp library and execute arbitrary code on the victim phone. So what we do is we use so the goal of our team is try to prevent similar attacks from happening again. And we use linter, we use fuzzing, we use static and dynamic tail analysis. So nothing here is new, but when we're trying to apply the techniques, we have some issue. For example, when we want to apply fuzzing for a library, so Facebook already have a pipeline for continuous fuzzing. It set up the environment on the cloud. They download the packages. They download the tool. They set up the coverage information, and everything is supported by controlled by bug. And it's the default build system at Facebook, and is well supported. It's very powerful, but it's only used at Facebook and not any other companies. On the other hand, at WhatsApp, we use CMake to build own of the system. So the first thing that we want to do when we want to fuzz a library is convert the CMake build files to the bug build file, and this is very expensive. To give you an idea, one very experienced engineer needs to spend like 1 month to convert one library. And because the engineers still continue to use CMake build file, this person needs to maintain the bug build file every day. And this manual conversion and also maintenance is very expensive. So one thing in our wish list is to automatically analyze the CMake build file and automatically convert to the bug build file. So that's one of the scenario. The second thing is, suppose we already have a 10 analysis tool that already support CMake. But if you look at this, suppose an engineer want to commit this code. So there is a buffer overflow here. If the user control data, it go to memcopy and it can cause buffer overflow. But this file, it only include in the build if the flag full is enabled. So when we run static analysis to analyze a program, we need to using this flag, and how can we do this automatically? So out of the scope of this talk, but to address this problem, we are trying to analyze, try to build a symbolic execution tool for CMake to try to figure out the command line. And there are many challenges when analyzing CMake. The first thing is, suppose you have this Python program, you can conclude immediately that the function bar doesn't change the variable a, and but in the case of CMake, is you can change a even it doesn't take a as an argument. So the scope of CMake is not at any other language that you know. And then the variable expansion is completely nightmare. So if you see in the line 1, we have it set full and bar at x, and then at line 4 it had a set of macro, but when after some replacement, it also go to full and bar, and then it's x. So if you think about symbolic execution, you have one symbolic variable on the left and of the value on the right, but here we have multiple symbolic variable due to this variable expansion. And another thing is in CMake, there only one data type, which is string, but it also acts like list. So based on the context, whether it can be considered as list or string, the expansion can be a lot different. So you can take a look at this example later. It have very weird, totally messed up variable expansion. And another thing is when we're talking about symbolic execution, we need to solve the constraint, and solving the string constraint is already hard. Now string constraint have list operation, so we cannot find any SMT solver that can handle this or string and list constraint. So I'm going to talk here because I feel like this is analyzing CMake build file very hard, and I cannot find any existing work on analyzing CMake. So I hope to raise awareness of. I think this is a interesting problem and need more attention from both academia and industry. Thank you.
Excellent, Sam. Thanks a lot. Coming up now, another software engineering practice paper. The title is Automatic Anti-Pattern Detection in Microservice Architectures Based on Distributed Tracing, from Jean Hubener, Yaping Lu, Peter Valen, Jonk van der Kogel, Toon Liefheid, and Michel Chaudron. Team, in the middle of the night, it's like 2 a.m. there. Feel free to share your screen and delight us with your talk.
Thanks. Yeah. Share my screen. Great. No. Okay. So seems to be working. Hi everyone. My name is Tim, and welcome to this presentation on automatic anti-pattern detection and microservice architectures based on distributed tracing. So just to get everyone on the same page with the microservice architecture, we define the idea of the architectural style as to develop a single application as a suite of small components called microservices. So in this slide, we have a single application with 4 services here on the right. And this architectural style has enabled large companies to scale the development of their applications as teams can work a lot more independently from each other. But how can we ensure that the architectural quality is not neglected during development? Because the teams, the code, and the decision processes are highly distributed throughout the companies, and teams usually only focus on the services they rely on or the services that rely on them. So it's difficult for a single person to have this holistic overview of the entire application and detect any anti-patterns, because they just see basically one step ahead. So we defined the following research questions. Can anti-patterns of microservice architectures be automatically identified from distributed tracing? And we were really motivated here by improving the quality of microservice architectures, making it easier to identify anti-patterns in large applications, because the example we just saw with 4 services is really easy, but with 400, this becomes a real challenge, and preventing any biases and evaluating the architecture. So now we can look at the results from our case study at ING. Here on the right, we can see a visualization of most services at ING, but collecting the data was already our first challenge we had to overcome, since the code artifacts are distributed across the entire company. We could not fall back on static analysis or repository mining. This is why we use the distributed tracing data to collect this data. Now, on the collected data, we used our methodology to detect the anti-patterns. And in our methodology, we first characterized the anti-patterns we wanted to detect. And we did this by defining a vector for each anti-pattern with service-based maintainability metrics and graph theory-based metrics. And next, we computed these vectors for each service from the data collection step. So now we have 2 vectors, and finally we can compute the vector distance between the 2 vectors and see which services express anti-pattern characteristics. However, this was very abstract, and therefore developers did not really engage with the results. So we wanted to visualize our findings to make the results more tangible for developers. And visualizing large graphs is a challenge by itself, but the results from the anti-pattern detection allowed us to use some tactics to improve the visualization. So the first thing we were able to do was to highlight basically the different anti-patterns within the within the context of the entire architecture. So here we highlight the 5 biggest mega services within the architecture, but we were also able to filter out services, in this case that had cyclic dependencies. So we could really see some interesting structures emerge within this application, and we could focus on these. And we were also able to add additional live information from the distributed tracing to confirm or disprove any anti-patterns that we detected. In this case, we had the business rules service that was detected as a bottleneck, and it also had very slow response rates. So we could basically focus on this service first. So to conclude, yes, we were able to detect anti-patterns and visualize, and the visualization tool was very useful, but the results need to be verified by a domain expert, because not everything that was flagged as an anti-pattern was actually an anti-pattern, and some anti-patterns were actually not as bad as expected. In future work, we want to do an in-depth validation of detected anti-patterns. So far, we were only able to do a sample. Improve the linking of the service metrics to anti-patterns. Want to measure the metrics over an extended period of time, and we want to add more context data points. So thank you very much. Thank you for your attention.
Thank you, Tim. Following Tim's presentation, we have a paper entitled Organizational Culture and its Impact on the BizDev Interface by Kaique Moreira, Breno de França, and Tayana Conti. Breno will present this paper. Breno, you have 5 minutes. Feel free to share your screen and go ahead.
Thank you, Igor. So this paper is about a concept that is very similar to DevOps, the idea of 2 functional areas of a software organization collaborating to achieve results together. But instead of going downstream on the software value chain, we go upstream and try to understand how the area of business and development collaborates to deliver a feature faster and in a healthier way. So for this, we conduct a case study in a Brazilian tech company. The main goal was to get empirical evidence on how the collaboration in this interface works. And we conducted 15 semi-structured interviews with people from with business and technical profiles, and we analyzed the data using ground theory procedures. The case company is a global leader in the market of mobile app for kids. And so it's entertainment app with contents like movies, pictures, some stories for kids and this kind of stuff. And they had a lot of interesting business units concentrated on developing content for the app, but they have also a lot of software development in it. So one of the main products was the parts that we are investigating. And so these 15 people, part of them were mobile development, backend and full stack development, and some guys from UX design. From the business sector, we got people engaging in product road mapping, content development and growth in terms of how the product evolves and sustain itself. We run the interviews in 2 phases. So we got almost a year to conduct, to collect the data from the interviews, and we have one trial analyzing the data, and then we improved the script to get better evidence and clear data about some aspects we didn't get in the first phase, and then we analyzed the second part of the interviews. The main phenomenon we identified in the case study regards the idea of development people acting in business activities. So they were they have software developers, software engineers working in prioritization of requirements, establishing value for the features, defining the features and the requirements, applying solutions for cost optimization, for example, and understanding how they could automate some recurring business demands. They work in an approach like we call it a data-driven behavior. They work constantly collecting data, collecting metrics and indicators from the production environment to understand the business and how the features of the products are actually impacting the business. And they use these metrics and indicators to make some benchmarking with competitors. And in this actuation, they actually idealized 2 new products for the company, and one of them actually start as a new business unit in the company. The main finding for this paper specifically, we identified from the interviews that the organization culture was the main motivator on why people from development teams are acting in business. So the idea of that one of the cultural values from the company is the sense of ownership was motivating developers to act in business activities, in business practice, to take this extra step and try to impact the business and try to get the feature and the product better. So they were more interested in trying to, how can I say, impact the final goal of the company. So they are trying to make the value appear. And also another cultural aspect regards the team that were very open to receive suggestions. But this kind of behavior also impact in a negative way in some parts of the process, because some of misalignment was happening, and some of the features were not really ready to be launched. So they delivered features that were not aligned with the business strategy, and some features or products did not succeed in these adventures. So they understood that it's a good opportunity to work together with the business the business sector, but they should do it in a responsible and a safe way. So the idea of the culture influenced people to work in this way, have positive and some negative impacts or results. And the challenge we state at the end of the paper is how we can use organizational culture to motivate people to work this way, but in establishing safety measures actually, or to work in a proper way.
Thank you, Breno. And the last paper of this session is on the effectiveness of machine learning experiment management tools. We will play a video for this paper, since the authors could not make it for this session. Simon, whenever you are able to do that.
All right. Can everybody see this?
Yep.
All right. I'm going to start playing.
Okay, hi everyone. Yes, my name is Samuel Idowu, and I will present our short paper titled On the Effectiveness of Machine Learning Experiment Management Tools. This is a joint work with Osman, Daniel Struber, and Torsten Berger. I'm a PhD student at Chalmers University of Gothenburg, Sweden. All right, so we know that machine learning has been found effective for current and future problems. And this has led to development of more and more systems, the machine learning-based software systems. And with this increase in development has also come a lot of engineering challenges, which has been discussed and highlighted in a number of studies, such as the one that is listed below in the footnote. And one of the areas that are commonly discussed has to do with how to effectively manage the assets, the extensive assets that is different from the typical software engineering assets, especially during the experimentation and a model prototyping phase. And this has led to an increase in surge of special class of tools called the experiment management tools. Which promises to address different experimentation concerns such as reproducibility, collaboration, traceability, and many others. And I have some example of those tools listed here. There are many more others. So this is some cloud service-based and some standalone software. And what they do is that they provide the developer or data scientist with the option of tracking the state of those assets for each of the run of their experimentation. And those assets are organized in a way that they can be queried to attend to different concerns like reproducibility and many others. For us, our motivation actually is from the fact that there's lack of mature integration with the traditional software engineering tool when we consider this class of tools. And also their lack of evidences on how effective those tools are from the user perspective. And because of this, we have a long-term goal of unifying these tools with the traditional software engineering tools, such as our IDEs. So based on that, we have two research areas or two research challenges. One is on finding out the tool effectiveness using the empirical tool evaluations. And secondly is the unification of these tools into the traditional software engineering tools. And The short paper that we've presented actually laid down 4 different steps in the research agenda form, which we think would help us to achieve this goal. And I will present those steps and the early results where it applies. So the first step is that we need to assess the usability and the effectiveness of this tool, because there is none or no studies looking into that yet from the user perspective. And for this, we actually propose the use of controlled experiments. And our early results shows that the tools, they do offer valuable support, and that there are different paradigms that those tools have that affect the effectiveness as perceived by the users. Secondly, we need to compare this class of tools with the software engineering tooling to understand the commonalities and the differences between them. And for this, we propose the use of feature-based survey, which uses domain analysis techniques. And for this, we also have an early result, which was published in the last EXE. Then we come to the next step, which is to design and prototype the tools. So for this, we propose the use of a meta model to represent the prototype conceptual structure. And also we consider unifying the superset meta model, which are customizable towards specialized tooling situation or prospective user or usage context. And lastly, to evaluate the unified tool, we propose the use of user studies and also the use of controlled experiments. But for this, we need to combine both the data science and software engineering activities when we design this sort of controlled experiment. And lastly, the use of action research to understand the user interaction and the tool benefits. So here are the 4 steps that are laid out in the research agenda and the early results. Yeah, thank you. So thank you. I think my time is up.
So thank all the authors for the presentations. Now we have 20-something minutes for discussion. Is there anyone in the audience or any author who wants to make any questions? If not, I can throw some.
I have one question for Christopher.
Leno?
Christopher, what is the background that you needed to the experience in this course? What's the software engineering background you need?
Okay, so the teams for the software engineering students, typically they go through first a 2-year sequence that is it's a software engineering first approach. So that they learn software engineering at the same time that they're learning the CS1, 2, 3 concepts, and then the 4th semester in that sequence, they do a semester-long project with an open source project. That particular cohort worked with OpenMRS, Open Medical Record System. Other more recent cohorts have worked on Pitivi, and so then that gets them through their first couple of years. And then in their 3rd year, they have their traditional senior design project, and also we put them through a leadership course. And so that was kind of the prerequisite chain that got them to where they could work on that project. They have, of course, in addition to that prerequisite chain. Did that answer the question?
Okay.
Yeah. It froze a little bit in the end, but I could get it.
Any other questions? Okay. Tayana, just make a question for Samuel. Samuel is not here, unfortunately, Tayana. It was a video. So, yeah. Let me ask a question. And Christopher, Christopher just answered a question. I'll leave it later. Tim, are there any patterns or anything, any suggested recommended solutions for the anti-patterns that you chose to try to find, to detect, or no? It's just like you're detecting, and it's up to the designers and developers to sort out how to solve it.
Yes, at the moment we don't do any recommendations on the patterns we find. So what we did was we actually then interviewed a couple of teams for the patterns that we detected. And some teams then said, okay, but this is exactly the design we wanted. This was especially the case with the bottleneck pattern, because the bottleneck pattern if you look at the numbers, it's like, if there are too many connections going through that one service, it's the bottleneck, but it's actually can provide an abstraction on the services that lie behind it. So it's actually the whole point of it that everything goes through it. So the main experts have to then validate if this is actually useful or not. But the other one, it was actually kind of known by the developers that everybody kind of knew, okay, this is a really bad service and it takes really long and it's down often. But we don't provide any solutions on, we don't provide any how to solve it. But it was more like a general, at the end of my studies at ING, I gave like a general statement on how I would help them, but that was not part of the paper.
The part of my follow-up question was answered there. So sometimes it's by design, and that's quite hard to understand if it's by design or not if you do not recommend and ask for someone's feedback. So it's a good that you sorted out two of my questions.
Okay.
And do you believe that? Do you believe that there are other metrics that should be considered other than the ones that you've used? Like, how did you choose them, or are there others that you could use to detect this anti-patterns?
Yes, certainly. So we have now used the graph theory-based metrics, which is then looking at how many incoming connections does a service have, or how many outgoing, or we can look at the in and outgoing of its direct dependent nodes. Well, if we then talk in graph theory, services become nodes. And we use the service-based maintainability metrics, which were a set of metrics that we got from a different paper from previous work. And there were a lot more of them, but we tested several, or basically all the metrics, and found that the ones we selected so far were the most useful, with then again the anti-patterns that we wanted to detect or were able to detect based on purely looking at these metrics. There were a couple of more we would want to consider, but we were more looking at can we get more context information? So like which teams develop which service? That would have been a really interesting metric to know, because there's also the anti-pattern of one team develops too many services. So if we know which team develops what, it would have been an easy anti-pattern to detect. Yes, and basically like more the throughput over a extended period of time. So actually the distributed tracing metrics, we only had them for live data, but we look at it at a historical point of view, that would be more interesting for the architectural aspect to it. So yeah, those were it.
Nice. Okay, great. Seems that there is a lot to work on that area, so that's great. Sebastian, I have a question for you. So thank you very much for exploring this EPSI topic in the classroom. The most interesting thing for me, at least, and maybe for others who are instructors here as well, is to understand if there are like a short list of do's and don'ts of this course that came out of this course, like some guidelines, fast guidelines. Is there anything like that?
Yes, of course. We found 14 studies of EPSI training in the past, and we try to follow the lesson learned by them. And one of the most important is that the EPSI courses must be very practical, you know, like doing a systematic review during the course or some activities like that, because systematic review, EPSI, are topics very complex to understand without practical tasks. So this is the most important. And then try to help students anytime they need it, because, for example, a lot of students try to read 50 papers in a week. No. So you have to help them and say, no, you must read 5, for example. So because they don't have a background about this is our experience. No, they don't have background from reading papers from interdisciplinary topics or topics without outside their expertise. So this is important also to support the students. I think that this is the two most important lessons learned: practical task and support their work.
And did you have like any assistants, like teaching assistants, or was there like a single instructor for this class? Because like being close to the students the whole time is seems like a hard task if you have let's say regularly medium-sized kind of course.
Yes, we were in the 3 first courses, we were 2 teachers, and we have at the maximum course like 20 students. This is a small number because it's very important to track their work. So this is a strong limitation. But now with the pandemic, we try to make videos of the topics, so that and try to the student to self-study the theoretical. So now we are trying to use this material to try to reach more students in one course.
Nice, great. This is great. Let's move on to Sang. You listed the challenges and that are still there for CMake analysis. And do you have any initiatives already in place to try to overcome some of these, or do you have any ideas on how to overcome? Which ones would you suggest starting with? It's not like the easiest or maybe the most important one to solve.
Yeah, so as I said, we are working on a simulate execution tool to analyze CMake, and yeah, we're trying to overcome some of the challenges using a particular data structure. So one of my the first co-author, Kim Hao, is here. He can provide more detail about it. It's out of the scope of the current paper, but if you need to any more detail, you can contact him.
Go ahead, Kim Hao.
Yes. So, so sorry, I think I missed the last one. So can you say the question again?
Oh, of course. Like, so I have two questions. Like, how do you plan to overcome or to address the challenges? Which one do you aim to start with? Which ones are the most challenging, the easiest, something like that? Do you plan to start with the most important one, the easiest one? How is it?
Oh, I see. So actually, we plan to simplify the CMake model. So instead of like treating everything as string, we will separate them as list and string, and that make the semantic easier to deal with. But then we are going to ignore most like edge cases that won't matter in real world, and then yes, I think that would simplify our implementation a lot. And then we will try to eliminate the side effects as much as possible. So we try to make the CMake program like a pure, just a pure program. So all the side effect would be just we model it like a mock, and we just assume that the command with same input would output the same output, and it will be true most cases. And that I think that would be one solution for our challenges.
Okay, thank you.
Yes, thank you.
So Christopher, now I'm really interested in understanding from the perspective of the responsible for the capstone project and the instructors involved. Like, what are the challenges here? Like, what can you say? Like, it's the most challenging thing from an external perspective here. It seems like partnering with industry solved a lot of questions here, but how easy is that to handle this partnership, and what are the other things that are hidden behind that?
Oh, sure. I mean, especially in that first year, it was a little scary for us because almost everything that they needed to learn was well outside our area of expertise. And then, but Don't Panic Labs, we'd already had a good relationship with them. They are they're probably the biggest champion outside of academia for our new major. In fact, they've now gone so far as to even say they're only going to hire people who majored in software engineering, which is both fantastic and, well, maybe a little monoculturish. But anyways, yeah, it requires trust. It requires you to go outside your comfort zone, recognizing that you have to get people who have the expertise in this, and then you have to trust them. And yeah, we sat in on those sessions too to make sure that that they actually did seem to be learning something. But we have to trust that the DPL guys were giving the industry best practices for it.
Nice. It looks like the name of the company fits really well with what you're going through.
I didn't even think of that.
So
Thank you.
Yeah, like it matched quite well in your discourse. Like, okay, then they were there. Like, Don't Panic Labs. Yeah, of course, right on time. Do you have any cases of success already? Like, they finished that, and did anyone like actually created a startup or any product that is under development still?
So both years, yes, they went ahead and formed an LLC. I don't know if that's just a U.S. specific thing. It's a limited liability corporation to kind of own the intellectual property and be the target of any lawsuits. So that first year, the LLC is still out there. They don't seem to have actually gone beyond the beta stage. So, given that most startups fail, maybe that's not so shocking. That the one this year, they formed their LLC, and they've released the demo. So this year they did a game. They did a video game. It's interesting. They've already got a publisher talking to them about selling it. So I look forward to seeing them actually succeed.
Nice. Good that we have a success case. It's always nice to sell it as a good endeavor, like in its 2 year only. Oh, great.
Yes.
Breno, still this training perspective, it seems like comfortable. on my side, I'll say. Do you think that people from IT would somehow receive some kind of training, since there's this huge wave of people working on biz dev, so it's more people from IT than business working on that side?
Yeah, actually, I believe that the directions you can find people going in both directions. So we have some kind of continued education courses on software engineering here, and we have a lot of students that are actually not from computer science or engineering or software engineering. They are from other areas and trying to embrace the market of building programs, platforms, and software in general. So we are getting people from business trying to understand more things from tech, and also some guys in technology that I believe they just get tired of coding, and they want to step up in the business area, and they actually succeed. One of the authors in the paper, actually the main author is a former master student. He got the master degree last month, and he's now a manager in the new company he's working. And he was a tech lead. So he starts growing on this business side of the company. So I believe this is a kind of a direction that people are searching for.
And do you think, like, based on your results, I can see that you mentioned a lot, like the culture of the company, the values, and etc. And this study was conducted in Brazil. So do you see that there is any kind of ethnical culture playing a role there? Do you see that this is something that other countries like are less social than culturally speaking than Brazilians? It would be the same, like maybe in a more hierarchical kind of companies, I would say, not only countries. Would the same thing happen? Or this is a natural because
I'm not sure about countries.
As
an evidence-based guy, I'm not allowed to say it without evidence, but I think not the country is only contributed, but the domain of the company. So it's about entertainment. So the guys working there are all about having fun and try to socialize, and they get try to have an impact on the users, the end users' life. So they want to deliver something that is useful, and they feel good about it and not just making money. And so this atmosphere is something that contributes for this kind of culture, I believe.
Great.
Yeah, I was thinking I would love to see your study basically replicated at the company I work now. I think it would be very different results.
Maybe actually we run a similar study before. I believe it's cited in the reference, but it was in the university, where it's a public university, and people are most of the workers are very old on their jobs, so they are not so fun, and they are not so social, and the interface, the BizDev interface there is quite different from this other company that we are studying now.
Yeah, this is a nice replication kind of study, like different companies, different cultures, like a multicultural kind of company, to see what
we need now a different country.
Yeah. So great. It was great. Like, it's 8:58, so it's time for us to close the session. So we allow people to move to other sessions. I would like to thank you, the authors and the attendants, very much, and best of luck.
Yeah, thank you for organizing.
Thank you.
Thank you.
Thank you.